Muhammad Amin, anaqa mikrofoningizni o'chira olasizmi? Chunki juda ham anaqa shovqin kelyapti. Okay, rahmat. Thank you. All right, Raj, I think we can start. Yes, because we have 4 people here, and Steve Johnson, it's Alex and Maruf, and they are together.
Okay. Okay, everyone. Can you hear me all clearly? Can you hear me, Shakzoda, clearly, yeah?
Yes, me,
Yeah,
yes.
Okay, great. If anyone's got a problem, yeah, just put it in the chat. Okay, yes, okay, cool. Okay, so yes, hi, everyone. Obviously, I think we've got people from 2 different times that we had the original session, but the session was exactly the same. So today the idea is to follow on from that particular session and progress, if you like, to the next to the next understanding of how to actually create an experiment. I would say from obviously, you know, going through that process, most of you understand the theoretical side of AI and machine learning, and obviously some of the coding aspects. And hopefully all of you understood and got value out of the last sessions where you understood how a problem statement or a challenge statement, as everybody wants to call it now, is found, and then obviously how you work on it. So we're going to go deeper into working on it. Ideally, we're going to have two separate teams, but we'll see about that. Okay, just to recap, just to sort of summarize from last time, if you remember, we always said, you know, companies, they look at investigation as to what happened. Okay, they'll do a, you know, end of year results, and then they look back and say, okay, this and this and this happened. How can we change it for next year? So data is never really a problem. Okay, there's plenty of data out there, and how you visualize it is obviously how each company will try to then make sense of obviously what to do with it, right? So if you see, there's plenty of dashboards like this. What they can't do is why. Finding out why something happened is very hard to do. And as we discussed, it's all about network effects. Okay, something that happens in Tashkent could have started in Dubai, right? There's you know, it could be 3 or 4 hops away, and the human intelligence is limited to find out why something happened. You need to find out why something happened so that you can stop the problem from happening. Okay, and that intervention has to be proportionate to the size of the problem or the challenge. There's no point spending $10 million to stop a problem that's $1 million. Okay, that's the idea of what we're trying to do. And then we discussed obviously trialing and how a trial would look like. A very simple code, very simple platform, just to show the company this is how you could have solved your particular problem had you applied AI. And how do you trial? You trial on their historical data. Okay, as we mentioned, each company has lots of data, and you can use that data to create an experiment. So this is what we touched on last week, sorry, 2 weeks ago, is there's a methodology to how companies should approach this. Most of them don't know how. So we take this as a Baikal company, we take this to the companies and we tell them this is the steps that we will take. And what you're going to learn today is obviously what those steps are, how they fit in, and how you would be part of that, and at what stage you would be part of it. Would you be the business analyst? Would you be the programmer? Would you be the coder? And this was again something we touched on in the original session. So if you remember, in the last session, we identified a problem statement in the UK, okay, that the police are having, and it's specific to stolen cars by organized criminals. Okay, so the problem statement is very, very sharply designed. And then we create a model, a trial period, which essentially is taking the business case through to the field verification. And this iterative process, this is where the AI takes place, whereas you're experimenting and you're modeling again and again, just so that you can get a more reliable model of what could have happened. And because you have historic data and you know what's happened, the AI can train on 80% of that data. And then on the 20% of the data, you can test if that model is accurate or not. Okay, that's what the real world companies should be doing. And then also we touched on a little bit about the obviously the planning. How do you actually put this together? And then you've got the separate job titles here in terms of and the sort of tasks that that take place. Okay, any questions from last time or any thoughts? You know, again, interrupt me anytime. You don't necessarily have to listen to me. You can interrupt anytime. Any questions or thoughts on this? Okay, right. So the important aspect which I touched on, I didn't go into detail, but we discussed it briefly, was the domain expert. Okay, so for each of the projects that we have, we always use a domain expert. That is somebody who's got experience at a high level within a company. They may have 30 something years, 20 years minimum is best. Okay, they understand AI and data science. That means they understand what it can do. Doesn't mean that they can program. They can also understand an academic paper. Again, not fully, but they do get what the academic is trying to do. And they could be a project manager. They must provide input into the features. Okay, and when it comes to the commercial side, it's always easier for them to sell to the company. Okay, so for our police project, this is our domain expert. As you can see here, he's been a chief superintendent. He's managed 300 staff. He ran Hertfordshire as a police force, and he looked after the murder team. So you can understand he understands policing very well, right? So he's been part of our team. And then we also have other people, which obviously you may have met at the at Avlo Hub before, so maybe more internal people. These are senior people with legal experience who are also helping the team. So everything is first problem statement and getting the expertise from the domain experts to help define the problem statement. Then we have academic input. All right, so where the problem statement has been researched, is there any research that has produced any algorithms? And then we need the academic input to the local market as well. All right, especially if we're bringing the technology from outside. Okay, and also if you have a local university involved, there's ongoing research potential as well. So once you've solved one problem, the idea is that locally there'll be more problems that you will find in that organization, and because you're already engaged with a university or other research institute, you can carry on solving other problems as well. Does that make sense to everyone? What the domain expert and the academic input, where that lies? Everybody understanding that? All right, I will continue. In our case, yeah. So in our case, we have a professor from the University of Kent, and he basically produced this paper. Okay, he basically produced the whole convoy analysis using ANPR data. He produced this back in 2016. So we've taken this existing algorithm and made it into a trial for the police. All right. So any other thoughts or ideas on what we've covered in the past? Everybody's clear on that, right? So the idea of today is you have to think about how do you actually put together a team and how do you put together a process when it comes to making an AI project. An AI project is not a fixed piece of work. You know, if you're making software, let's say for CRM, or you're making software for messaging app, it's usually a requirement. You do the code, you test it, and you then supply it. The difference with an AI project is that because it's always changing and there are unknown elements, i.e., some of the outcomes, you don't know why they happened. And the modeling, you may have said, okay, we're going to do 1,000 models. You may end up doing 5,000 models. You may end up doing 500 models. There's lots of elements you don't know. Okay. So within a team, can anyone suggest what other types of job titles may be needed, or what sort of description of jobs would be needed within an AI team? Does anybody know? Anybody have any ideas? Testers, yeah, possibly Dilshad. What would those testers be doing? What would they be doing? What are they testing? What else?
Data application engineers.
Yeah, Satish, not for you, is it? Yeah, not for you, Satish, unfortunately. Anyway, project manager, okay. All right, we're getting there. And you got data engineer. Okay. What else? Anything else? HR manager, we can put it in Dalston, but I don't think we really need a. That's more of you actually having a company. Sorry, HR manager. Yeah, that's right, Alex Murov, system admin. Now, system admin, you can actually outsource that out. You don't necessarily have to have it as part of the team, especially when it's at a trial phase, because the trial is designed not to be that big anyway. So you may have a third party, or you might just use some cloud or something like that to do that. But anything else? All right. So, oh, So if you look at this, what we're basically saying is that we need a domain expert, and we need an academic. Right, that's what, like I said, the way that we operate. A lot of companies won't bother with the academic. Okay, they may not necessarily think that that's important to have. Domain experts they will have internally themselves, right? But the academic, we feel that's the wrong thing, isn't it? From our research and understanding, we conclude that the academic input, especially in the UK, is a big advantage, because what you're doing is you're finding a problem that's already been researched by somebody, and also you'll have a unique technology because of that, because the university will only produce technology and research that's not been produced before. Okay, so then you also have a patent, if everybody understands what a patent is, if the technology works and the technology scales. So from a business perspective, the academic input provides a lot more value as well. Okay, and then you've got stuff here. I mean, you could even add, if you wanted to, someone like a software programmer, if you wanted to make an MVP or a wireframe as part of the outcome as well, that could be needed, right? So I think you get the idea, right? Now, I think these three jobs here are what, unfortunately, I think who's in the thing? So Dildora, I think you were here last time, weren't you, Dildora? You were there. No, Dilshot. No, Dildora's not here, is she, Shagzola?
Yes, no,
Aziza,
she's not here.
she's not here. Nor is Aziza.
Aziza also, she's not
Also
here. Yeah.
not here. Okay. Okay. So the business analyst part was obviously what we were trying to talk to them about. But we can, now that we have Mirza, I remember you. You've got Steve Johnson. Mohammed, were you here before on a different session? Was Mohammed here before?
I think no, I think it's his first time. Muhammad Amin, شو تامسس بزavlamsız.
I think Abdul was here
Shu.
before.
Oldin kelgansiz a anaqaga или birinchi martami?
O'quv markaziylariga borganman, tadbirga.
Birinchisiga keluvdingiz a?
Ha.
Okay, yeah. He actually was on the first session. Yeah.
He was on the first one. Oh, okay, good,
Yeah.
good. Okay, so the idea of today, now we had two sessions, and we had obviously the first session was about cement plant and why it was closing, and the other one was Dildora had mentioned the extreme heat in Tashkent at the time. So I think Dilshad, you were part of the heat one, wasn't you? In which fair you were, because you said can you? I'm saying you were part of the session when we discussed the problem statement of excess heat, the high temperatures in Tashkent, right? Yes. Okay. Cool. Cool. And who else was in that session? Anyone else?
I think we had Mirzo as well at the last session with Dildora, Mirzo, and it was Dilshot, if I'm not mistaken.
Dilshad.
Yes.
So Mirza, you were part of that one as well? I can't remember extreme heat. Do you remember the cement one, Mirza? It's going to be difficult if nobody actually wants to talk. Cement maybe yes. Okay, Mirza. Okay, fine. Are you guys able to actually speak? Are you in a position to speak rather than type? Alex and Maruf, can you talk?
Yeah, here.
Oh, you're here. Okay.
Yeah,
So let's try. Yeah. So let's try this, right? The idea is, right, what we were going to try and do is basically have two teams. Okay. So one was meant to be obviously on the cement plant. Obviously, if you remember the problem statement, it'd be good if obviously we'll go through that. And the other one we discussed on the second one was the extreme heat and the problems that that was causing. Okay. And the idea is to look at the challenge statement. Then we will look at obviously what the cost is, and then we look at obviously the data points, and then we'll try to build a solution. Not actually program one, but what elements are needed to build a solution. Okay. And the idea was to obviously go into, have two separate teams, and one team would do one, and one team would do the other. But obviously, I think we're limited in terms of the second group coming. So, if you remember, Alex and Maruf, on the cement one, do you remember some of the problems we said that's closing? Why the cement plant may close?
Actually, we had left the session.
Oh yeah, that's
Yeah.
right. You left it. Yeah. Okay,
Yeah.
that's true. Yeah. Okay. So what we had discussed at the time was, you remember? Do you remember? Did we talk about cement plant when you were there?
Yeah.
Yeah. Okay. So
we
what?
we
Sorry, go on.
we developed a program to combat some problems, and that are related to electricity, and
Yeah, we have talked to predict the problems, future problems.
Yeah. Predict the future failures, right?
Yeah, future failures.
Okay. And so we discussed plant failure, health and safety issues, obviously power failures, and some of the discussion was around having sensors on the equipment, having measuring the electricity current, and then having external sources of data. Okay.
Yeah.
Is there anything else you can think of that we should add to this that would help to predict what sort of other things may happen in terms of failures? Why else would the plant fail, and what data sets we could add to this? Okay, we will warm up to that one. So on the cement plant, the estimated cost, right? First of all, they said the cement plant said 45 days per year are lost in production. This equaled 60,000 per day. So what is the total loss in a year?
2.7 million.
There you go. So 2.7 million per year. So based on this, would you say that this is a problem statement that is worth looking into?
yeah.
This is to everyone. Yeah, this is to everyone. This is to everyone.
Yeah.
It is worth it, right?
Yeah, for
Why?
sure. Because company is losing much more money.
So so the company is losing 2.7 million, right? But if you look in, so think about it from your own perspective. So company loses 2.7 million, right? So just imagine you're going to the boss of the company, 20% of the annual income. Okay, that's a good point. Abroad as well represents 2.7, which is 20% of annual income. Right. Do you think this is the only company that has this type of problem?
Certainly not.
Sorry, I didn't hear that. Say that again. Is this the only company that has this type of problem? Alex, Maruf, anyone? No, there would be a lot, right? So,
So
right. So many other companies, right? So other companies will have,
Same issues.
yeah, or same or similar, right? Similar issues. So in theory, if you've got 5 companies with the same problem, it becomes $10 million plus challenge, right?
yeah,
Okay, so that's how you got to think of it. Because once, as you know, as software people, once you produce the software one time, you can replicate it many times. Okay, so when it goes back to what I said to you in terms of the academic input, if there is an academic who's put, created a solution around this, and it is something that we can, have a patent on. Does everybody understand what a patent means?
Yeah.
Yeah.
Yeah. of
Okay. So,
course.
right. So once it has a patent, then you know. So what you're saying to the company is, what you're saying to the cement companies, look, if you let us test this, one, we can solve your $2.7 million problem, potentially. And secondly, we can then apply that software to other places and you can have a percentage of that as well. That's the general pitch behind this. All right. So it's not it's very logical, right? In terms of what the offering is. Does that make sense to everyone? It's probably a different model to what you've experienced or what you hear about, but this is actually possible with companies. All right. So the thing is, you've got to be creative. I think that's the one thing that we're trying to get across today, is that you have to be creative in your solution. The cement company doesn't really know how to solve this, right? Does not, because if they know how to solve it, they would have solved it, right? They're not going to lose $2.7 million every year. That's not what they're going to do. That's why they're having the issue. Right? How to solve the problem. Right? So you as a somebody who's going to help them, what data points do you need? Now, obviously, no one here is an expert on cement companies, right? So don't worry too much about right or wrong answer. But what do you think is needed in terms of data points? Based on what we said earlier before. Well, yes, Dilshot, statistical data of what? What is statistical data? What do you mean? What? Tell me. Selling cement. Okay. Cement sales, volume of production. Right. What else? Extra cements. Okay. What else? You know, Dilshot, you have to explain why we need this data.
I think company expenses.
Company expenses.
Yeah,
Okay. What else? What else? Right. So your materials, they call it, to produce manufacture cement. All right, what else?
The logistics.
Who was that? Yeah, another coin. It's not for you. Supply chain. Okay. The other stuff is the machinery. If you remember, so Alex, I think you guys and Mary, if you'd
And
gone,
the
but
machinery. Oh, you
yeah,
already
it's
wrote
not-
it.
yeah. So machinery, you need to know. Need to know age of machine, when it is serviced. Need to know age of the machine, when it is serviced. Cost of servicing. Right? How much electricity is consumed? Right? Who operates the machine? Right? How long the machine is running? Okay, so if we look at the how many free requests from stock per year? Yeah, Dilshad, why are you asking about the stock and the production? Why do you think those data points are important? The whole point of it, because of the request. So what? You mean the order? Are you talking about the order? Yes, if a company needs to make 1 million tons of cement, yeah. But then how does that data help with the detection of when the machine will fail, that they will have a closure? Yeah, you're not thinking of you have to think of the relevant data set that you need that will tell you why the machine is failing, why the production machine is failing. How will the orders give you that information? What are you looking for in that data? Or why do you think? Again, there's no right or wrong answer, right? So the whole idea of the session today is to try and listen, is try to understand what we're doing. Right? From what I can see, this is, I mean, obviously I know a bit more, so that's why I'm saying it. But the machinery side is your starting point. Okay? If you have these data points, then you know everything about the machine. And you know about the staff. Yeah, you know about the staffing, how much electricity is being consumed. So if it starts consuming more electricity, it means that there'll be more problems in the machinery. You understand? So that's what we need to try and do. The other the new data we can get is to put IoT sensors on the machine itself. Right? This will measure the vibration. Okay. Don't forget, this exercise is not to get you an expert into cement machinery, but just to make you think openly. Okay, based on the knowledge that you have in technology, what can we use in a cement manufacturer to reduce how many days it is closed? Okay, so just try and think on that basis, because the cement company, they don't always know, do they? Because like I say again, if they knew, they would have solved this problem themselves. All right. So based on what I've written here, is there anything else you can think of that we need?
Raj, what about the head level?
What level?
Heat.
Heat. Oh, you
I
mean
mean,
the environment?
yeah. About the machinery in summer is it's become more hotter.
Right. So that's
That's
true.
the
So in the
yeah,
sorry.
no, it's not about the electricity. It's about the running of the machine. The
Yeah.
time of
So in the summer, yeah, it could be that there's not enough cooling or something, And so
Yeah,
in the
exactly.
summer, yeah, in the summer you may find 50% of the closures happen in
About
June and
40%,
July.
you lost it 40%, but in autumn you like exceeded on more 20.
Yeah. At what times does the plant close? Okay, that makes sense, right, everyone? Doston, Dilshad, Abdul, Maruf, Alex. Yeah. Okay, good. Okay. So you see now, when it comes to any problem statement, you're not going to know exactly what to ask for. The domain expert would give you this information in most cases, but you have to give some information. So if you were going into a meeting about cement manufacturing, you may have to do, you will have to do half a day's research to look into that. All right, that's going to be part of the exercise that would take place. Okay, so now that we've got our data sets, right? Can anyone see it? So as I think Noricon sort of touched on it, are there any possible, from the human eye, are there any possible connections between the data points? Right? This is quite good in terms of, normally the domain expert would do this, right? To help you in your initial trial. So as Noricon said, you've got the heat of summer and closure, right? That's one. Okay. Sorry. Sorry. Can you say that again? Can you say that again? All right, hold on. No, sorry. Catering. I don't know what that means. Okay. What? Shakzoda is in Uzbek.
Catering, maybe.
Oh, okay. To repeat. Oh, for me to repeat. So what are the possible connect? Oh no, okay. Okay. So I'm gonna let you repeat.
It's a question for Nader Khan. Nader
Right.
Khan, can you please repeat your last question? I think Dilshad is asking you.
A second, I'm about to stop in a minute, okay?
Okay. He'll be back in a few minutes.
Okay. So in the possible data connection points, you've got, and also you might have the operator, the worker, and the closure. Okay, so there could be one person who's operating the machine wrong, right? That's possible. You may have age of the machine and the closure. And then you may have supply chain, right? So it could be the materials, it could be the machine parts, it could be issues. So this is really not for you to answer, but this is something you would ask the domain expert or the company, because it gives you some very, very quick analysis to say, okay, can I make some connections here between the outcome, which is the failure of the machine or the closure of the company, and what the domain expert can see straight away. All right, is that clear to everyone? This is not for you to answer, but for you to ask the domain expert, what are the possible connections of data points that are obvious, right? Which are the most easy ones, which as people in, because we don't work in cement factories, we are not going to know. All right. So don't ever think that you can't ask somebody, and you don't ask the IT, you have to ask the operator. All right. You have to ask the business person what these connections might be. And the good thing is they may actually start thinking of more. So we've had this situation with our domain expert, especially in the policing one, that once they actually start looking at the data points and you start connecting some data points manually, they then can see, okay, there's other things that they could have missed, but they can now actually start to connect as well. Usually you'll find that they will give you ideas of connecting very, very small pieces of data to the outcome, because they have a feeling, right? So when somebody has worked 20, 30 years in a company, because you guys are all very young, right? But there are people there that have worked 20 or 30 years in a company, and they can look at data and they have what they call as a feeling, right? That because of these issues on data here, that is what is causing the closure. But it's very hard to prove unless you apply a computer model to it. Okay, and that's what you're trying to do. When you interview the domain expert, you should get this type of information from them. All right, is that clear to everyone? Because that's a bit different to maybe how you might normally operate, or how you might normally think to operate. Okay, good. So are there any other connection points that you can think of, or any other questions you would ask to a domain expert? What else would you ask them? Yeah. Have a think. Alex?
Hey
Murray?
guys, I'm back. So can you repeat that question again? What was the point?
It's in the chat, I think, as well.
Oh, check it out.
Why is it hard? Oh,
Ha,
sorry, go on.
mana aytayotgani mana machinery ishlashiga, mana anaqalarni оборудование ishlashiga yozgi vaqtda, ya'ni temperatura o'zi qizigan vaqtda ular unchalik ko'proq ishlab bera olmaydi. Ya'ni temperaturani o'zi baland bo'lgan vaqtda, plus оборудование ishlayotgan vaqtda u taxminan 40% ga kam ishlaydi. Lekin kuzgi vaqtga, havo salqinlashgan vaqtda plus 20% anonsi bilan ishlashi mumkin. То есть ko'p производстводagi, mana masalan o'zimda ham zavodim bor edi, ana uгол chiqarardik biz, uгольный briketlar chiqarardik. Yozgi periodga bizning ishimiz to'xtardi deb ayta olmayman, lekin yozgi periodga juda qiyin bo'lardi, chunki o'sha briketlarni ishlab chiqaruvchi zavodimiz tez qizib qolardi. Основном o'sha qishki periodlarga ishladi. Eshitildi?
Yes, it normalizes, yes. That is true,
Hey,
that is true. So, yeah.
Are you with me? Did you hear that?
I heard that, yes. Yeah, I saw that, yeah, that's fine. So the machine
Did you hear
KPI, yes, I got that. Can you hear me? Yeah, I heard that.
Yeah,
Did everybody hear
yeah.
that? Yeah. So we're just talking about the data points and the connectivity between them, and that might be an initial question you may ask a domain expert. Okay, because normally most people can connect 2, maybe 3 sets of data to a particular problem. The human can anyway. So the idea here is if you ask a domain expert in terms of connecting a number of data points, then what you're doing here is you're able to then use the AI to connect a multiple number of data points to find a better outcome. Okay, so but then, like I said, the domain expert is best placed for this. Can a manufacturer cement or something so that sales won't start during time and lost from? Yeah, you're right. That's right, Abro. If you know that that there's going to be a production issue, then you potentially could do more production. But the idea behind this is that what is the cheapest way to do it? I mean, overproducing and having overstock is always going to be hard. Whereas if you do something just in time, when the orders are coming, then your machine runs a lot more efficiently. Yeah. So, but that's a good point, Abdul. That's the sort of question you should ask the domain expert, right? You ask the company that, right? You shouldn't be afraid of asking these types of questions because again, they may not have thought of this or they have thought of it and they do maybe over manufacture it, but then obviously they have a storage cost. So if they have a storage cost, you can then say by doing a prediction and detecting failures in plant machinery before it happens will save you this much in storage. Okay, so it's those types of questions that you need to ask, you need to think of. All right, and then that's what I'm saying. Main thing is don't worry. If you have the right domain expert or the right company, they won't mind you asking questions because they know you're not experts. But as I said before, you must make sure you do some homework and that you research the topic before you speak to anyone as well. They're not expecting you to know this 100%, but they are expecting you to do some work behind it so that these types of questions are relevant and that you know they know roughly that you are talking the same language. If you think about it, the easiest, not the easiest, one of the other ways is the research paper, right? If there is somebody who's done, if there is a university that has done the research in this field, let's say cement, I showed you obviously the police one, then these questions are not needed because they've done the work for you, right? So now can you all see the value of a research paper?
There's one more thing. There should be the place where we're talking about the construction and building periods. For example, here in Uzbekistan, all the construction and building periods are starting on summer. That means that concrete should be already ready in spring.
Yeah, well, we don't know that. I mean, that's the point being is we're making assumptions. That's a question you would ask the company. What is their production cycle?
Yeah,
And what do they lose? But we don't.
Wait,
Yeah, that's what I'm saying.
they have
Yeah,
a high cycle period.
yeah, but we don't know that for sure, right? So that's a question you would ask, right? Of that, you know, you're going to be doing construction in summer, so building up to that, what's your production cycle, and what can we do to make sure you maintain that production cycle? But as I was making the point to everyone, does everybody understand where the academic paper, right, where university has done the research on a topic, could be, you know, valuable in this exercise? Abro, Dilshad, Alex, Maruf. Yeah, you understand. Good, good. Okay. All right. So, what are the possible experiments you would run in this particular situation? Oh, the lights are on. Now that you've got your data sets, you've got your questions, and this is a bit more technical. Do you have any ideas what sort of experiments to run? And I have no answers to this, right? So I'm thinking the same thing as you guys. What is it that you would run as an experiment? Okay. How is that relevant? Dostan, the main problem is that the plant is closing due to machinery failure. The cement plant is closing due to machinery failure. You understand, Tishindima, Dostan? Okay. Okay, so what would we have? as,
What problems are causing the machines to fail?
Yeah, that's what we're trying to find out.
Yes. We are checking the climate change, or it's because stuffs are not working correctly, or
Yeah. No, so Dostan, you're not understanding. We've got the problem statement. Okay, we went through what is being lost. We discussed why, what data points they are. So it could be because of humans, but we don't know. So what technology do we use? How do we take the data of the number of employees and the machine failing? How do we connect this now? Yeah, what data are we analyzing here?
Mm,
Do you understand, Dodson?
yes, I understood.
Yeah, so you got to think through now. What is it that you're trying to find, for the use of a better word, you're trying to find initial correlation, right? So you got data points that are connected. So we know the heat of summer. So if the first thing you do is you look at the temperature, you look at the June and July, August months, and let's say 40% of the closures are happening during those 3 months. So there's a heat problem, right? Is the machine failing because the heat is too much? So that's one experiment that you would run, right?
Right.
Right. Second one you might do. Second one you might do is on the cost of the no, it's not the cost. Sorry, on the maintenance that is happening. So is the maintenance of the machinery happening too late? Yeah. Are there other machines that don't fail because the maintenance, you know, the replacement of the motor, let's say, is being done early? Okay, guys. So you need to think about this. Don't worry about getting it wrong, but just like I said, it's good, Dostan, that you're coming up with this. What is it that you think you need to answer here? What data sets are you mashing? And do you use a simple linear regression, or are you trying to find, and are you trying to do anomaly detection?
I think that the plant should have a problem statement cycle too. Like if it is a plant, there is a problem statement cycle too. Like they already know at what time what machinery goes out, or they got the problems with the up and running. So
No,
we
but
can cycle it. We can also run the cycle too to see the problem statements. Is it really like this or not?
yeah, no, the whole point is they're not going to know that, are they?
Yeah, they will, because this factory is not built like in 2 days, or is working like over 3 or 4 years, and they should have the like statistics, the data of the problem statements, what they're gonna
No,
have.
so they'll have some of the data,
Yeah, they
which we
have some of
discussed
the
before.
data, but maybe
So-
we could use those problem statements to implant it to AI to like look through it. Like
So that's what we're talking about then. So that's what we're talking about. What is it that we need to do with regards to this? This then comes down to the technical people. So yeah, so Abril, you're talking about reinforcement learning.
we need to
Expand on
run
that.
cycle.
Hold on. Abril's written reinforcement learning. What do you mean by reinforcement learning? As much as we have much valuable data at the beginning. What do you mean by that, Abril?
You are asking what is the reinforcement learning?
What is the what? Sorry.
You gave a question.
Yeah. So we've got data sets, right? We've got the problem statements. Let's say we've got all of this data that you see here. Yeah, we've got all of this data. You know, all this data is available. So the company gives you the data and now says, okay, build me something where I can detect before the machinery will fail, before my plant has to close. So I'm saying to you, what experiments at the beginning do you run?
I'll run the
This
whole
sounds.
cycle.
You may speak.
Go on.
This sounds like a classification problem, maybe. Yeah.
Okay. Okay.
We might have some data, and according to that, we might build a simple logistic regression at first, and check it if it works perfect or not, and later hire someone to gather more data by watching out the machines and learning the causes for their failure and etc.
Okay. So hold on. So basically, look, classification, right?
Yes.
So the classification is, what does a failure look like, right?
Yes.
And then what you can do it. Sorry, go on.
This is binary classification.
Yeah.
And logistic regression works perfect for binary classification.
Okay.
But you might also try neural networks like maybe fully connected neural.
There's too much background noise from somewhere.
Maruf, can you please turn off your microphone?
Okay, sorry, carry on.
We might use neural networks, some kind of like fully connected neural networks, or maybe take some of the images of the machines that broke or that are available for working, then use convolutional neural networks. This can also help in some cases, but in many cases, people prefer using neural networks because they are just working perfectly lately. In order to neural networks, neural networks don't have much more data to be trained. But as you have many data, the accuracy of your model will be higher. It depends
Okay,
on your data.
depends on the data. So going back to the classification, right? So where we have what a failure looks like. Once you label that as a failure, then shouldn't we classify what a n-1 failure is and n-2?
You are talking about reinforcement learning. Yeah.
Well, basically. So if you look at again, we don't know this, right? So you have a machine, and it's producing, let's say, 100 kilograms of cement every day. Okay, and let's say before the machine fails, it produces 80 kilograms of cement. So therefore, before the machine fails, there's 20 kilograms of less cement because it's running slowly, let's say, less slowly, right? But you don't notice it because it might be 3 or 4 kilograms a day that is being not being produced. Again, we're making assumptions here, right? But what I'm trying to give you an example of is you have your end outcome, you label that, you classify that, and then you look for those steps beforehand. What's an n-1? What's an n-2? What's the over your temporal, your time? Can you break down the outcome and then classify that as well? Does that make sense to everyone?
In order to remember what was n-1 or n-2 failure was, we should use maybe recurrent neural networks like LSTM, long short-term memory.
Oh, yeah, okay.
Because it has memory that can even remember what was the last output from the last neuron. This is a perfect way to use in such situation.
Exactly. So again, what you've done there is basically what you're doing is you're using the application of a traditional theory, but you're applying it to a cement factory problem, right?
Mhm.
The cement factory owner will most likely look at this as a binary situation because maybe they're too busy, they have other things going on. But if you can classify, so if you take n is the failure, n is the time when there's a failure. If you can find n-1, n-2, maybe up to n-10 events that lead to the n failure, and then you apply LSTM, there you go. You've got your classification model then, haven't you?
Yes.
Okay. And then you're applying those other data sets. Yeah. So you made, so now the only data set you have at the moment is when it fails. Now you're looking back, maybe applying, like I said, it could be the electricity data, it could be the production volume. You're looking for some pattern, just one indication where there might be an n-1 where the machine failed. But sorry, where the machine was working. But there's a road path to it failing. So this is the type of data. So going back to, remember what we talked about, the data engineers. Where is it? Here. So when we talk about the solution itself, you're trying to get the domain expert to give you that information. You as the data scientist are trying to obviously provide the different solutions and experiments that can be done. But at the same time, you want the data management and the data engineer to help you classify those different data sets. Does that make sense to everyone?
Yes, makes
Yeah,
sense.
but where are the AI developers?
Yeah, this is AI.
Oh, this is all AI.
Yeah,
Okay.
so the AI developers is too much of a generic term. We can't really sort of say AI developers. I mean, in essence,
Maybe AI specialists, maybe.
yeah. But this is the AI. This is you say AI team more than anything. You don't have such thing as an AI engineer.
Then we
Everything
need to
comes
write it
on.
out like an AI team, so
Yeah,
to make it more clear.
but yeah. I mean, the other guys they know that. So okay, so you see my point. So you see that, guys. Everybody else, you see where this is going at. Within the data sets that you have, you would probably break down 2 or 3 of them from the beginning, get your outcome, mark that as n, and then mark that as, and then look backwards, mark everything as n-1, n-2. See if you can code, obviously, that into an LSTM type functionality. You run that as an algorithm on the historic data, and let's assume that there's millions, let's assume there's hundreds and thousands of lines of data. You find those patterns, and then you keep classifying, and you can even break it down even more, right? But don't forget, in an experiment, you may have limited time. So it's very easy to start thinking, okay, I'm going to get this down to n-100. You may not have time for that, right? Because all you're trying to show to the cement factory owner is, look, from your historic data in this short period, I could have saved you 3%. I could have saved you 5%, right? In terms of failures by this prediction. Only when you make the full model is that when you might go into the n minus, multiple double-digit numbers. Is that clear for everyone? Does that sort of make everybody understand what we're trying to do?
Yep, it's clear enough.
Because we can go into deeper things about, obviously, the different types of algorithms that we can use. And by all means, if anyone's got any ideas, they should. But like I say, you're
Actually, the
trying.
cement is made of clinker, so each 1 ton of clinker gives about 1.2 ton of cement.
Sorry,
Do we have this data here somewhere?
what's that now?
Each 1 ton of clinker gives 1.2 tons of cement.
Right.
So do we have this kind of data here? So I mean, there's a brand of the cement too, like brand 400, brand 800, and 600. Each brand needs different kind of materials, not the different kind of materials, like more clinker. So do we like classify them with the different brands, or we're just talking about one brand of cement here?
Well, why does the brand matter?
Because it's different in payment. So each mark that each brand that is like 400, 600, and 800, it become expensive, and it gets on the money.
Yeah, but I mean, in terms of the factory closing, yes, you will have more losses. But in terms of the question here, does it help the experiment in any way?
I mean,
He's asking
I'm looking at
about
this.
he's asking about there is a quality in the cement, and he wants to classify according to the quality. Am I right?
Oh,
Yeah, exactly.
yes. If you classify under quality, then yes, okay. So you have a more expensive cement that will have a bigger problem statement, right?
Exactly. So
Yeah.
each
So I see your point.
classified, yeah, each classified points is like going or expensive or cheaper. So that means
So
that the problem statement for the factory is different.
no, so what? So well, yeah, the problem statement of the factory is different, but in the experiment side of it, personally, I wouldn't go into that sort of granularity. I wouldn't go into that detail, because when you're experimenting, you want to be able to do a quick show to the end user that you understand what the problem is, and you're classifying data overall. If you have 2 lines of cement or 3 lines of grade of cement, yes, maybe then you might have a classification into different outcomes, right? So you might have an N outcome, an M outcome, a P outcome. Okay, fine. That's not such a big deal. But what we're trying to say in the experiment stage, which might only be 3 weeks, it might be 12 weeks. Okay,
Yeah,
you
but
want to do it.
when we're
You want to do a
coming
quick
back
test.
to the experiment, we can just run the whole cycle like several times and see would it, or rather it would be like the same each round or not.
No. So because what you're doing it off historical data. So what we're saying here that
okay.
yeah, you're only running this on a historical data. So you've already got all the outcomes in that data. So so the experiment you're trying to run is classification. What does a failure look like? You've got different data sets.
See the pictures.
All right, you've got different data sets here. So within these data sets, so for instance, volume of production, you're making cement, extra cement after. If you take the failure, let's say the failure date is the 27th of June. Okay, on the 27th of June, where did the data sit for all of these particular data points? Right, were the sales down? Probably yes. Were the logistics down? Probably yes. Okay, that's your N, right? That's the closure. N is your closure of plant. So N minus 1. Okay, let's look at N minus 1. What was the electricity consumption on N minus 1? What was electricity consumption on N minus 2? Now that minus 1 could be 1 month, could be 1 week, could be 1 day, could be 1 year. That's for you to decide. Yeah. So then going again onto the heat. Okay, again, so your N event on the 27th of June, the plant closed. What was the temperature on day N? It was 42 degrees. Okay, so N minus 1. Do you want to do it a day before? Do you want to do it a week before? What makes sense to find the temperature? Anyone have a guess? Anyone have a guess? Have a guess. 1 day, 5 days, 7 days?
It is, but to understand in how much time the machinery worked in this kind of temperature. So
Yeah,
which
so do you want to
degree
know a
of,
day before? Or do you want to know a week before?
yeah,
Which one?
yes, I'll take it
So
like
look,
1 week maybe.
so N minus 1 becomes your 1 week. Okay, that's an
Can
experiment.
can you repeat the question?
Okay, so n is your event, the day of your event. On the
Understand the
20th,
critical degree.
let me explain it to Abo. He's asking. So on n is the day of failure, right?
Mm-hmm.
All right. So n. This is the in temporal analytics. N is always your day of the event. So on
Mhm.
the day n, you've got data for production, which is 0. You've got data for electricity use, which is 0. You've got the temperature outside. You've got the number of workers. You'll have the number of cement sold. You'll have the machine age data. You'll have the machine condition in terms of any recent maintenance. You'll have lots and lots of data for n. So you classify all of your data sets, and you tell the computer will say on this day that's n. So what do you do as your n-1? So Nodicon said for the temperature, n-1 should be the temperature 1 week ago. Okay, which is according to
time series problems.
exactly.
5 days is the best choice, I think.
Well, no. So again, this is why this is an experiment. In my view, I would say n-1 would be a day before. So I have to do, yeah. So but
Yes.
that's my thinking, right? So this is the creative part. You've got to have. There's no right answer and there's no wrong answer. In every close, can we collect in one time? What do you mean close? Close? What does that mean? But you see what I mean? So n-1 could be 1 week, could be 1 day, could be 1 year. It depends on what experiment you're running. You can
Yes.
run it for 5, yeah. So you can run it for 5 days, but at least you've put it in your system that it's 5 days. Now you might take the electricity output or the electricity current, and you might do n-1 a day before, n-2 2 days before. Yeah, of course you can. So Dilshot, that's the idea. In every point, you can collect data at one time, but you may have some data that only comes in maybe a week's usage. You may have some data that is a 7-day, but you adjust your model for that. So when it comes to classification of data, that's part of the initial work you have to do. You have to label what your key points are, right? So in this case, we think the machinery is the main point of failure. So that becomes your outcome. It could be that the human is the problem, but we don't know that yet, right? We're assuming it's the machinery. So take machinery stopping as the right So, but the point I'm making is there's no right or wrong answer. This is all down to how you, as data scientists, as business analysts, you have to decide and say what are your events that you're looking to target. If you talk to a company like this, so this is a $2.7 million problem. Okay, so let's say you say to the company, we're going to charge you $100,000 and we're going to solve this problem for you. That $100,000 will be half $500,000 saving for you. And say the company says yes, or let's say $50,000. It doesn't matter, right? You're going to give them a figure. They've got to give you historical data. You then have maybe 4 weeks, you may have 6 weeks, you may have 8 weeks, whatever you've said to the company. In that period of time, can you run an experiment to show where the points of failure are, what the events are, and how the algorithms that you create or that you use can detect where the points of failure are, so the company can then adjust so it doesn't have closures. And you're running experiments. There's no right way, there's no wrong way. You're creating the product as you work on this. All right, does that make sense for everyone?
Yes, yes.
Yeah. Alex, Maruf, Abroad, Dilshad.
Actually, Alex and Maruf, they left the meeting because their internet connection was really, really bad. So they
Okay.
had to leave, yes.
You recorded this anyway, right?
Yes, it's in
Yeah.
recording.
It's in recording. Okay.
Yeah.
Yeah. So so does that make sense to? So obviously this is the guys. Yeah, it makes sense. Okay, Robin. Yeah, But you see, so when it comes to designing of the actual project, the more data sets there are, the more complex your trial may be. But it doesn't mean you use all of those data sets. By talking to the domain expert, and if you have the academic, you're then able to shorten your period of trial, because they will give you some indication of as to what patterns to look for. Yeah, and you're not looking to solve the problem from $2.7 million to zero. That's going to be very hard to do. $2.7 million to $2.5 million is still a big win. Yeah, because the AI should start looking for the outcomes. Once you classify the N and you can start applying AI tools to that, and you have that stream of data coming in, and you're able to get the machine to get the self-learning algorithms in place, then that will self-improve over time. That's a different discussion we'll have when it comes about programming. But hopefully you get a bit more of an idea today how to actually produce an end-to-end system. Obviously, on the technical side, you guys will know a lot more, and we can go deeper into things like that. And perhaps we can actually get a use case. We'll try and talk to a company, see if they're prepared to give us some actual figures, and maybe try this. If everybody's, we'll have a chat on the group, on the AI focus group, to see if this is worth us doing, and we may be able to get the data for this if everyone's interested in doing this. Unless anybody's got any other questions or thoughts, I think it pretty much covers for today.
When will the next session be?
Shakzoda, over to you.
All right. Yeah, thank you very much for your question, Dostan. We will see. We will make a vote as usual, because we want everyone can join sessions. So we will see, but I think during this week, right, Raj, we can do our next session. Maybe
Yeah, it
at
would
the
be
end
good.
of this, maybe at the end of this week, maybe on Friday.
We could try and do that.
Yes, at this time.
If I think if you and I can have a conversation tomorrow or something early, then it would be interesting to see what we can do for that.
Okay, all right,
Yeah.
perfect. We will, yes, we will make a poll in our group chat.
Any other points from anyone, even from the outside people? Anyone want to say anything?
Yes.
Otherwise, we will leave it for today. But yeah, I mean, hopefully, to the guys remaining, Dilshad, Abor, and Mohammed, it was good. And
Yeah,
Dostan as
and
well.
for
Yeah, thanks for your
Dostan as well.
contribution, Dostan. Yeah,
Yes.
Dostan was good.
And Raj, thank you very much for your like presentation explanation.
No problem, no problem. I will share the presentation as per Dilshad's request. I will give it on the group.
All right, perfect.
All right.
Yes.
I'll add to the groups, okay?
Sorry?
Add me to group, okay?
Okay.
I'm out of it.
All right.
Cool. Thank you, everyone.
Thank you so
Thank you.
much, Raj. Thank you everyone
problem.
for being active. Thank you, and see you on our next session, guys.
Thank you for
Yeah.
your time.
Thank you,
Thanks.
Dostan.
Bye-bye.
Yes.
Thanks, guys.